All right, so this is your reference sheet for 7.1 and 7.2. These are all the things we need to know. So we started with reciprocal identities. So when you see a single trig function, okay, and it's one of the reciprocal ones, we can replace it with 1 over its reciprocal. So cosecant 1 over sine, secant 1 over cosine. Cotangent has 2 options. It can either be 1 over tangent or it can be cosine over sine. And then tangent could be 1 over cotangent or it could be sine over cosine. Then came our Pythagorean identities. So these 3, sine squared plus cosine squared equals 1, tangent squared plus 1 equals secant squared, 1 plus cotangent squared equals cosecant squared. You want to start to train yourself to see squareds in your problems. So if it's a squared function plus a 1, come back to these and see if one of them works. If it's a squared function plus another squared function or a squared function minus a squared function, come back to these and see if you can substitute them in. Sometimes you get a squared times a squared, and it's less likely those use Pythagorean identities, but it could happen. Then comes the even and odd functions. So as soon as you see a negative on an angle, come back to these. If it says sine of negative x, I replace that with negative sine of x. If it says cosine of negative x, I replace it with just cosine. The negative goes away. And if it says tangent of negative x, I do negative tangent of x. Then we said this would be the same case for our reciprocal functions. So cosecant of x, cosecant of negative x, would equal negative cosecant of x. Secant of negative x would actually go back positive to be secant of x. Cotangent of negative x would be negative cotangent x. So the reciprocal functions take on the same characteristics as the initial ones. And then we didn't have any of the cofunctions yesterday, but you'll see them today. Things that are pi over 2 minus an angle. So that angle here is u, but it could be theta, it could be x, it's the same thing. And we replace sine of that with the cosine. Cosine of pi over 2 minus the angle would be replaced with sine. Tangent goes with cotangent, and secant goes with cosecant. So you want to have all this stuff, like, obviously you can use a reference sheet for your quiz and test, but you want to know it so well that you're not digging through this to try to find what you need. All right, so we left off with number 9. And I skipped these. I said to skip these because remember they had different trig functions, but were along the factoring ones. So I can't factor something that said like let's just say this said y squared minus x minus 3. You couldn't factor that because those are completely different variables, right? The same is true for my trig functions. I can't factor this because one is cosecant and one is cotangent. But if you go back to that reference sheet, do you see something on this reference sheet that links cosecant with cotangent? Okay, so 1 plus cotangent squared x equals cosecant squared x. So I can't, there's no 1 plus cotangent squared, there's just cotangent, which means I'm not replacing that. But in this one, there is a cosecant squared. So I can take this cosecant squared and I can replace it with what it equals in my Pythagorean identity, which is 1 plus cotangent squared x, and then minus cotangent x minus 3. Now I've got like terms. One is squared and one isn't. That's not me. Let's try that again. Okay. So again, now we've got the same trig function, right? One is squared and one is raised to the first power. So I'm going to combine my like terms in the 1 and the negative 3, and I'll rewrite this as cotangent squared x minus cotangent x minus 3. Then I can say A equals cotangent if we want to substitute it in, and I would get A squared minus A minus 3.
Why is it minus 3?
Should be minus 2. I said I was combining, and I didn't. Minus 2. I got distracted by the poltergeist. Sorry. Okay. Should be minus 2. And then I want to see if I can factor this. So are there factors of negative 2 that sum to negative 1? They would. Good. Positive 1. But remember that A was cotangent. So really I want to plug that back in here, and I'd get cotangent x minus 2 times cotangent x plus 1. So that's your simplifying by factoring, which sometimes doesn't look like it's much simpler, but because we're trying to factor it, it is. All right, now look at 10. Again, we've got something squared, something not squared, and the number, which means we're usually going to factor something. But these are not like terms. So where on my reference sheet is there a link between secant and tangent? Tangent squared x plus 1 equals secant squared x. So there's not a tangent squared in my little expression here, but there is a secant squared. So I'm going to replace that with tangent squared x plus 1 plus 3 tan x plus 1. Again, combine my like terms, tan squared x plus 3 tan x plus 2. Now this time let's try to do it without plugging in for the a. Can I just factor this straight up? Instead of the a at the beginning, it would be tangent x and tan x. And then I'm looking for factors of positive 2 that sum to positive 3, which would be what? 1 and 2. And that's as factored as it gets. There was another slide of all factoring, which was similar to this, except they were the same trig function. You just had to factor it. And then there's very different ones, which some of them we're going to get to now, but the beginning ones were like just simplifying. So you'll see, like when you go through your slides, it simplifies first, then it says simplify by factoring, and those are similar to what we just did. And then, okay, so this is like a factoring. It said factor the expression, right? But the order is weird, so you can always rearrange this. I could do sine to the fourth x minus 2 sine to the second x plus 1. If the signs throw you off, you could say, I take the middle term, so this time it would be sine squared. I could say a equals sine squared, and so it would be a squared minus 2a plus 1. Then I'd factor it, so a minus 1 and a minus 1. But then a is sine squared, so it would be sine squared x minus 1. Sine squared x minus 1. And then as soon as you see the sine squared and the 1, hopefully it reminds you, check your Pythagorean identities, sine squared x plus cosine squared x equals 1. Rearrange that so it's 1 sine minus 1. That means I'm moving the 1 here and the cosine there. So it'd be sine squared x minus 1 equals negative cosine squared x. And then I'd get negative cosine squared x times negative cosine squared x. The negative times the negative becomes positive. Cosine squared times cosine squared is cosine to the fourth x.
Did you do number 3?
Mm-hmm.
Wait, let me just take a picture of that.
Madeline, what was the last number in your number 3?
3.
Okay.
How did you, just really quick, never mind, I figured it out. Just kidding.
Are you sure? Okay. I love when you answer your own questions. I'm glad I could be so helpful. So like that, right, Madeline?
Yes, but I had a 3 instead of all my cosines.
All of them, all the way from the beginning?
Yes.
Okay. Then it said factor the expression. So there's 4 terms. We're going to factor by grouping. I'm going to group these and these. From the first one, I can take out a 3 cotangent squared x. And it would just be 1 cotangent x plus 1. Then I can take out a 3, and it would be cotangent x plus 1. So then the cotangent x plus 1 comes out, and then 3 cotangent squared x plus 3 would go next to it. I can actually take this 3 out, so it'd be 3, and then it'd be cotangent x plus 1, and cotangent squared x plus 1. Now the cotangent x plus 1 I can't do anything with, but the cotangent squared x plus 1 should tell you go back to your your Pythagorean identities, and you should get 1 plus cotangent squared x equals cosecant squared x. So 1 plus cotangent squared can be replaced with cosecant squared. And that's as simplified as it gets. So some of you had the 3 and some of you didn't. If you didn't, it was just the cotangent x plus 1 and this cosecant squared x. Other questions?
Can we go back to number 9?
The left side of this. I said I'd come back and do the right side. So there's no squareds, and start to think, rule out process of elimination on that reference sheet. There's no squareds, so I'm not even going to look at my Pythagorean identities for these. Okay. At the beginning, so for number 12, the very first examples on that first slide, we could factor there was the same trig function on both, and we factored it out. That's not happening here, right? I have cosecant on one, and then I have cosine and cotangent on the other. So then we started to say, take these reciprocal functions and start to write them in their reciprocal form. So somehow rewrite them in terms of sine and cosine. What would cosecant be? 1 over sine, right? Cosine is going to stay cosine. What is cotangent in terms of sine and cosine? Cosine over sine. Cotangent is either 1 over tan or cosine over sine. And because we're doing these in terms of cosine and sine, that's why we chose that one. So if I combine the numerator there on the right, I have 1 over sine x minus cosine squared x over sine. Are my denominators the same? Yes. So I can combine this into one fraction. 1 minus cosine squared x over sine x. Then what? What is 1 minus cosine squared? Remember, it's sine squared x plus cosine squared x equals 1. So if I move the cosine on this side so that it says sine squared x equals 1 minus cosine squared x, what can I replace 1 minus cosine squared x with?
So I just have to
Sine squared x.
Good. You have to what?
So you just have to know that can happen.
Yep. So you want to start to train yourself to see things like squareds, right? Not necessarily by itself all the time, but like a squared with a 1, go to your Pythagorean identities and see if those are 2 of the 3 things that are in that. Because it's a 1 and a cosine squared, I went to the cosine sine one. If it was a 1 and a tangent, I'd go to that one. If it was a 1 and a secant, I'd go to that one. Can I simplify this?
Yes.
Good. It's like 2 sections of this, and then it's different. So it's not, you don't have to hate the whole chapter. Thank goodness. Yeah. It's not everybody's favorite. It gets better, but it's not everybody's favorite. All right, let's look at 14. Do they have the same denominator? No. If I wanted to get them to have the same denominator, what would I have to do?
Like, get the same. Like, Pythagorean identities.
There's no squares there to replace. So if you're thinking squared, that you would see maybe one minus sign squared, then I'd go Pythagorean identities. But they have to be squared. So I'm going to just work to get them the same denominator. So think about if it was just like 1 over 1 plus x plus 1 over 1 minus x. Pretend they were just regular variables. How would I get them to be the same denominator? The least common denominator is the product of the two. So this is going to go over 1 plus sine x and 1 minus sine x. To get that like denominator, the first one I'm going to have to multiply by 1 minus sine x. And the second one I'm going to have to multiply by 1 plus sine x. Right? By whatever is missing from the denominator. So I'd get 1 times this, which is 1 minus sine of x, over 1 plus sine of x, 1 minus sine of x. You don't have to do this stuff. I'm just showing you the process. Plus 1 times this, which would be 1 plus sine of x, over 1 plus sine of x times 1 minus sine of x. Denominators are the same, so now I can add the numerators. 1 minus sine of x plus 1 plus sine of x over 1 plus sine of x times 1 minus sine of x. What can I do in that numerator?
Combine like terms.
Good. So 1 plus 1 would be 2. Negative sign and positive sign actually cancel out. Now, what happens if I multiply this out? So let me write the 2 on the side. It's the difference of two squares. 1 plus something, 1 minus something, right? So the shortcut is square the first one, square the second one, put a minus between. If you don't catch it, then FOIL it out. It'd be 1 minus sine of x plus sine of x plus sine squared x. These would go away. Sorry, minus sine. And I'd get 1 minus sine squared x. Now what? Am I done?
So isn't that go with the Pythagorean something?
Good. The Pythagorean something. Yes. I don't care if you know the name of it. Sine squared x plus cosine squared x equals 1. Whoa. Equals 1. So 1 minus sine squared, the sine came over here, would equal what?
2 over cosine squared x.
Good. Can I get any simpler than that?
Yes.
What is 1 over cosine squared x?
Cosecant.
So close.
What?
It's secant. So you can actually bring any function from the bottom to the top or the top to the bottom by making its reciprocal function. So I can bring that to the top and make it secant squared.
But why?
Because then I get rid of the fraction, which is way more simpler.
Can you zoom out a little bit, please?
That's very complicated.
That one was hard.
Thank you.
You're welcome. All right, last slide before we get into the homework questions. So this one says 1 over 1 plus sine times 1 minus sine of x over 1 minus sine of x.
That should be 1.
Sure? But then what?
I'm not sure yet.
It's like a dead end. So let's pretend it's not, it is 1, but let's pretend it's not 1. What else could we do? Multiply straight across. So I'd get 1 minus sine of x over, what's 1 plus sine of x times 1 minus sine of x?
1 minus sine of x
Sine squared, right?
squared.
Difference of 2 squares again, right? So I could FOIL it out, 1 minus sine of x plus sine of x minus sine x squared, or sine squared x.
Does that equal half?
What?
Oh, wait, never mind, just kidding. I'm gonna do that.
Okay. Now what?
The bottom could be cosine.
Good. Sine squared plus cosine squared equals 1. So 1 minus sine squared would be cosine squared. Now here's the other fun thing that you can do with the fractions. If the fraction is if the sum or difference is in the top, I can actually split this and give them both the denominator. So I can make it 1 over cosine squared of x minus sine x over cosine squared x. So you can split it. Think about it. If it had the same like denominator, we could combine it, which means if the sum or difference is in the top, we can split them. What is 1 over cosine squared x?
Secant.
Secant squared. Good. And then I can separate this one out. I can make it sine of x over cosine of x times 1 over cosine of x. So there's 2 cosines in the bottom. As long as I keep it as a product, I can write them separately. So then secant squared x is going to stay as it is. But what's sine over cosine?
Tangent.
Tangent. And what's 1 over cosine?
Secant.
Secant.
Could you have gotten all that from the 1 over
No.
1 plus secant?
Oh, the what?
The 1 over 1 plus sine x?
If you lost the 1? No.
No.
So you can factor out a secant here, but it doesn't make it any less complicated, okay? So it's fine to leave it the way that it is. It would have been secant times secant minus tangent, and that's, you can't simplify it. So,
Miss Weiser,
yeah,
why can't you just like cancel out the second half?
the second half.
Like
This
minus
one.
Sine x and
So then
1
you get
yeah.
stuck, yeah, that's what Vanessa was saying. Then you get stuck here,
So why can't you just do that?
because it's not as simple as it gets.
So how do you know when to like?
That's the hardest part. If you get like if you're at a 1 step and you're at a dead end, something's probably wrong. You want to go back to the beginning. That's why 7-2 is a little bit easier, because 7-2 actually says this equals this, and you have to work to get the left side to equal the right side. So you have a goal. You know what you want to get to. So that's why 7-2 is a little bit easier. They tend to be somewhat more complicated, and in web assign, the homework is so strange for 7-2 because it leaves out part of these steps. But that's where we're working towards. So the hardest part, to be honest, is figuring out when you are simplified the most. If there's fractions, you usually want to get rid of them. So like this, because if there's a fraction and there's something in the bottom, something's wrong, I usually can keep going.
Okay, thank you.
You're welcome. All right, I think this one's a little bit easier, but let's see if we can figure it out. So I've got cosine squared, and then I've got 1 over sine. There's no tangents or cotangents or anything to like rewrite as the reciprocal functions, right? I can't rewrite 1 minus sine in the bottom. So what could I do with cosine that would allow me to go a step further? Cosine squared.
Separated.
You can only separate it if the sum or difference is in the top. So if it was 1 minus sine over cosine squared, then I'd separate it.
Square root.
Mm-mm.
Oh, okay.
Where else on that reference sheet do you see a cosine squared? Not where else, where?
Sine squared x plus cosine squared x equals
So if I had cosine by itself, what would it equal?
1 minus sine squared x.
Okay.
Oh, it's just 1.
Nope. So what you can't do, remember yesterday we said we can't do this, right? I can't cancel through part of it. It's a sum or difference, so it's got to be the whole thing. But what can I do with 1 minus sine squared?
Where did you get that?
So cosine squared, right? Because sine squared plus cosine squared equals 1. So I got it here. Hang on. I took this and arranged it so cosine was on the side by itself. So I moved sine to be on the other side by the 1. Is 1 a perfect square?
Yeah.
Is sine squared a perfect square? Is there a minus between them?
Yeah.
What do we call that?
A perfect square.
Difference
Difference
of two squares. How do we factor the difference of two squares?
1 plus sine squared x,
1 plus sine and 1 minus sine. Now do we see something we could do?
Cancel.
Yep. The step process here is to get it to equal 1, okay?
Is this for website?
This is number 11 on WebAssign. So yours might be different because the trig function might be different, but you're just going to do this one because it's the only one that has the pi over 2. So these to me are the most obvious. As soon as you see a pi over 2 minus an angle, you're going to go to the cofunctions part of your reference sheet. And you should see that the cotangent of pi over 2 minus theta equals what? Tangent of theta. So instead of cotangent pi over 2 minus theta, we're going to write tangent of theta times cotangent of theta. Then, what?
Wait. So, how?
This whole thing is that. It's, so we literally place that whole thing.
It's just tangent.
That becomes tangent, yep. And then what? What can I do there?
And put the cotangent over. Oh, it's 1 over tangent.
Good. And then what?
And then you multiply it, and then it's tangent over tangent. So
Good. So who has something other than cotangent for that? Give me what you got.
Tangent. It's the same thing, just tangent.
Oh, okay. Is that the only other version of that? That's not fun. And then this one says tan here. Yeah, okay. So again, if it's reversed, tan pi over 2 minus theta equals cotangent pi over 2. Cotangent theta. So then this would get replaced with cotangent. And then this would be 1 over tangent times tangent. And it's 1 equals 1. Questions on that one? So that's the only one that on the homework that had the pi over 2, so I want to make sure we went over something with that. I think they're the most obvious because they say pi over 2 minus an angle. If you see that, go directly to your cofunctions. All right, so listen to me. I don't want you to do not do Was that the first one, 11? Yeah, don't do 12 through 15. I know that this means that your grade on WebAssign is going to be bad. And I know that that's going to be hard. Do not do 12 through 15. I know that's going to be hard for some of you, okay? But don't do it. We didn't start 7.2 yet. I think, honestly, I hate the format of these anyways. I'll probably give you a PDF when we get into 7.2. So please disregard them. I can't change it. I don't think if I change it, it will update it on your end. I'm going to try, and we'll see if it'll update it. But I think once you've started, if I edit the assignment, it keeps it the way you already had. So I don't want to mess with it. I'm going to delete. Let's see if it'll save. I just don't want you to get new questions, that's all. So again, do not freak out if your WebAssign score is horrible, okay? And if you get frustrated and if it's wrong on WebAssign, even the other ones, remember that as long as you have the work at the attempt of it, you're okay. You cannot leave these blank. You have to try something. You should be able to do something in that. For 1 through 11, I'm expecting to see some work. 11 could be like this. You don't even have to type in the steps. But you should, for 1 through 11, I should see something. Ideally, you get it right, but if not, it's okay too.